Okay. So for today, like I said, it's really kind of an easy day. Um Now, when you're talking about relationships, generally you have and we're going to be doing this a whole bunch, but generally this is when lines are parallel, then they're cut by a transversal. Certain things are true. All right. Now, they're saying that do the lines actually have to be parallel? No, the lines don't have to be parallel, but if they are parallel, then there are certain things that are true. All right. Now, what we want to do today, though, is we just want to talk about interior, exterior, consecutive interior. I never really understood why people had trouble with these words. All right, until I figured out that they didn't realize they were talking about the parallel lines or the two lines that were being cut by a transversal. All right. Transversal is just a line that goes through two other lines. All right. Now, again, this is on the what? Inside. All of this here is on the inside. All of this over here is on the what? Outside, which we'll call the what? Exterior and interior. All right. So again, I never understood what the big deal was here. All right. So now we'll look at the interior angles. All right. I'll never really ask you for the interior angles, but the interior angles in our picture would be 3, 4, 5, 6. Everybody okay with that? And the exterior angles would be 1, 2, 7, and 8. Is everybody okay with that? If you understand that, it's relatively easy. All right. Now, alternate interior means the angles that are on the inside that are on opposite sides of the transversal. So when you look at alternate interior angles, you would say 3 and 5 are alternate interior. And the other set of alternate interiors are what? 4 and 6. All right, so we know what the interiors, we know what alternate interior, we know exterior. And now what are the alternate exterior angles? 2 and 8 and 1 and 7. All right, I just don't know what's difficult about that at all. All right, don't be confused. The words have meaning. All right. Now, consecutive interior. Well, if you're not alternating, then you are what? Consecutive. Consecutive just means they're on the same side of the transversal. All right, they're on the same side. All right, some geometry books call them same side interior angles. All right, but we're going to call them consecutive interior angles. So 3 and 6 are considered consecutive interior, and what else? 4 and 5. Those are considered consecutive interiors. Now, they don't really have consecutive exterior angles, all right, for some reason. All right, consecutive exterior angles is not a thing. All right. Now, the only one that might cause some problem is corresponding. But I tell kids all the time, don't worry about corresponding. Angle 2 corresponds to angle 6 because it's on the right side of the transversal and on top of the two lines. Just like 3 and 7 are what? Corresponding angles because they are on the right side, but on the bottom. And then you can say 1 and 5 are corresponding because they are on the left and on the top. That's what's meant by corresponding. All right. And finally, 4 and 8 are also considered corresponding because they are on the left side and on the bottom. That is it. That's what you have to know. All right. And honestly, we did a whole unit in pre-algebra on this. All right, so this isn't a mystery. And we all know that angles 5 and 6 add up to what? 180. Does anybody remember the rules for the parallel lines cut by a transversal? What's true about all of the acute angles? They are equal. That is correct. If the lines are parallel, all of the acute angles are equal, and that will be easy to prove, and we will be doing that. And all of the obtuse angles are what? All of the obtuse angles are equal. And again, we will be proving that. And anytime you have an obtuse and an acute, they will always do what? Say it again. They will always do what? Equal 180. It's really that simple. All right. How do I know that? Because right here, I have an obtuse next to a acute, which makes them add up to 180. Is everybody with me on that? Super duper easy. Super easy. All right. So that's it for that. All right. Let's scroll down to the next bit of information. All right. Now we can just talk about them. So again, this is where you're writing on your paper for your homework. I'll just collect it first thing in the morning. We might even be done early today. All right. 1 and 8. What is 1 and 8 called? 1 and 8. Help me out, guys. Tell me. Alternate exterior. Right. Now, first of all, again, I don't know what the hesitation was. Does everybody agree that 1 and 8 is on the outside of the parallel lines? Well, they're not really parallel, but on the outside, correct? And they're on opposite sides. That's why they call them alternate exterior. All right. So alternate exterior. 2 and 4. We agree? We're good. Corresponding. Anybody have a problem with that? Or what about 3 and 6? 3 and 6, guys, come on. Alternate interior, thank you very much. And then 6 and 7. Same side interior or, yeah, consecutive interior angles. All right, everybody's good with that. All right, here we go. All right, now what I want to do is we're going to go back and discuss what has to be true if they are parallel. All right, what has to be true if they are parallel. Now, so I know, I guess I could take the time to prove it real quick, but I think it'll be easy. Here's 2 lines cut by a transversal. All right, we are going to say that the corresponding angles are congruent. Corresponding angles are congruent, and that's going to be considered a what? That's a postulate. All right. So it's called the corresponding angle postulate. Do I really care if you write down corresponding angle theorem by accident? I really don't. All right. Because it just as well could have been the alternate interior angle postulate, because we will use this postulate to prove the others. All right. So right now, you are going to write it as the corresponding angle postulate. All right. Everything else is alternate interior angle, and that would be a theorem. All right. Alternate interior angles are what? Alternate interior angles are, help me out, guys. They are what? They're congruent. All right. I'm going to go ahead and just do the proofs real quick, just so you can see it. All right, the alternate interior angles are congruent. All right, so let me just go ahead and write this proof out. All right. I'm sure we're going to be doing it anyway. All right, so you have to be given that two lines are parallel. All right, the two lines are parallel. So if I call this angle 1 and I call this angle 2, what's true about angle 1 and 2?
34.
Because
Second section.
someone help him. Because they're what?
Postulate, you can say.
Yeah, what kind of postulate was that though? Yeah, the corresponding angle postulate. All right, corresponding angle postulate. All right, now for me, I don't really write that out. I just write corresponding angles are what? Congruent. All right, corresponding angles are congruent. All right. Now, what we're going to do is we're going to mark this angle 3. We're now going to prove that alternate interior angles are congruent. All right, we're going to prove alternate interior angles are congruent. So here is our statements and here are our reasons. All right. Now, basically the given would be two parallel lines cut by a transversal. Two parallel lines cut by a transversal. And we'll just call these L and M. And we'll call this N. So step 1, L is parallel to M. Given. All right. So now based off of that information right there, what do you have to say is true? Angle what? Well, let's just say angle, what's true about angle 1 and angle 2? They are congruent. That's exactly right. So you can say angle 1 is congruent to angle 2, and that is corresponding angles are congruent. Corresponding angles are congruent. All right, so now what else can we say? And sorry, I should have put this up there. We're proving that angle 3 is congruent to angle 2. That's what we're trying to prove. What do we got, guys? Come on. Oh, come on. There's a 3 there for a reason. You got to incorporate 3.
Angle 2 is like the alternate.
Yeah, but that's what we're trying to prove.
I know,
All right.
yeah.
We're trying to prove that. So we can't say that 2 is congruent to 3 yet. Once we prove this today, then we'll always be able to say alternate interior angles are congruent. It's a theorem after we prove it. All right. So you won't have to prove it after today. All right. Tell us. Yes. Angle 1 is congruent to angle 3. And they are what? Vertical angles. Very good. So now 1 and 3 are congruent. So if 1 is congruent to 2 and 1 is congruent to 3, then it's safe to say what? Yes. Angle 3 is congruent to angle 2, and that's just by a quick what? Yeah, that's a quick substitution. It's really that easy. All right, it's really that easy. Anybody have any questions with that? All right, so again, everything stems from the corresponding angle postulates. All right, Now, if I wanted to prove, and just all you have to do is pay attention now. If I wanted to prove alternate exterior angles are congruent, is there really a difference to the proof? No, right? It's the same thing. All right, it's the same thing. All right. Now, the one thing we do want to take a look at is if I made this, for example, let's say this angle 4, what's true about angle 2 and angle 4? What?
They're like supplementary.
They are in fact supplementary. Thank you very much. And how do we know that? They're what? Yeah, well, that's true. All right, and you will be able to say that from now on after we prove it. But let's quickly try to prove that angle 2 and angle 4 are supplementary. All right, they add up to 180. So tell me real quick, how can I do that?
Well, we know that 1 and 2 are the corresponding angles.
That's true.
So it's like a linear pair, 4 is not supplementary to 1.
All right, so they form a linear pair, right? That's the linear pair postulate. Angle 1 and angle 4 form a linear pair postulate. If they form a linear pair, that means angle 1 and 4 are what? Supplementary. And because 1 and 4 are supplementary, you can now say that 2 and 4 are supplementary. Come on now. All right, we don't have to write that down. Is everybody good with that? Anybody have any questions with that? 1 and 4 form a linear pair. That's from the linear pair postulate. 1 and 4, because they form a linear pair, are supplementary. 1 and 2 are congruent. Therefore, we can make a substitution and say 2 and 4 are also supplementary. All right. That's all under the condition, what must be true about lines L and M? They have to be parallel. Just to show you, look right up here. If they're not parallel, does it hold true anymore about those angles? Did everybody see? It's not true. They must be what? The lines must be parallel in order for that to be true. All right. Anybody have any questions? So again, corresponding angles are congruent. Alternate interior angles are congruent. Alternate exterior angles are congruent. And consecutive interior angles are what? Supplementary. Now, again, it's not really that big of a deal because anytime you have an obtuse angle paired up with a acute angle, we know it's always going to be what? Supplementary. Thank you. Add up to 180. If we have two obtuse angles, we know they're going to be what? Congruent. If I have two acute angles, we know they're going to be what? That's how easy it is. Even if you don't remember any of the names, you ought to be able to look at it and say, well, one's obtuse, one's acute, they must be equal, or they must add up to 180. If they're both obtuse, they're equal. Both acute, they're equal. It's really nothing to it. All right. I never understood the confusion. All right. So now that we've done that, let's go back now and make sure we knock everything out. So angle 1 is 94 degrees. Right. So I'll give you a second. You can draw the figure real quick. We don't even have to answer the questions. Just draw two parallel lines cut by a transversal. And you don't even have to put the numbers in there. Just put all the measures. Angle 1, angle 2, angle 3, 4, 5, 6, 7, and 8. Just put all the numbers. All right. See how good you are. See if you remember this from 6th grade. Yeah, you did. It's in the book. All right. So what's angle 2? Someone tell me what angle 2 is. Come on, guys. 86. Everybody's good with that? So now every obtuse angle is going to be what? And every acute is going to be, right, so angle 8 is how many degrees? 86 degrees. Angle 7, 94 degrees. Angle 6, 86 degrees. Angle 4, and angle 3 and 5, 94 degrees. Anybody have any issues with that? Anybody? Pretty simple. All right, pretty simple. And in this case, all of the odds are 94 and all the evens are 86. All right, I agree. That was simple. All right. Now let's just review one more time, guys. 2 and 6. Come on, everybody. 2 and 6. Those are called what angles? Definitely not corresponding. Alternate interior. All right. The difference is both the angles are on the inside. 3 and 7 are what? Alternate interior. 1 and 5. 8 and 4. Now we have 1 and 3. And now what if we said 7 and 6?
Same spot consecutive.
Consecutive interior. All right. Thank you for that. All right. So anybody have any questions naming these? Very simple. All right. So let's knock out the next one. Angle 4 is 101. You don't even have to write this one down. If angle 4 is 101, what is the measure of angle 2? 101. What's the measure of angle 6? And what's 8? Right? Does everybody see how we're doing that? Right? I always just look at the vertical angles. Right? Those are always equal. All right. And then you just do the supplements and then the verticals. All right. So all the odds are 79 degrees and all the evens are 101. All right. I'm pretty happy with that, guys. That's kind of easy. All right. So here we go. I need help with X and Y for number 12. What is it? What's X? 125. Everybody agree with that? What is it?
Actually, yes, I agree.
Thank you. And what's Y then? Everybody happy with that? 125 and 125. Okay. And 13. What do we got for 13? X is obviously just what? Be careful. Say it. Yeah, 114, right? X equals 114. Because what's true about these two angles, guys? They're congruent. All right, they're alternate exterior angles. So X minus 10 equals 104. You got to be careful. All right, easy to make mistakes. All right. Now, sometimes it's hard. I will make it so it's obvious what goes where. All right. But that angle is 2x minus 15, and the other one is x plus 55. So we can just say x equals what? X equals what? Am I just... I'm not sure what y'all are doing. What is the answer to 14? 70? Shrugging your shoulders, no one knows besides Tanner. Those are what type of angles? This angle and this angle. Yeah, alternate interior. So 2x minus 15 equals x plus 55. Everybody with me on that? So x equals 70. Right, x equals 70. Okay, so I'm gonna give you two hard ones. All right, I want you guys to try to figure out 48 and 49. Honestly, I think it's easy. All right, I think you can even fill in that proof. I think we kind of did it already. All right. But anyway, that's it for me. All right, you guys finish up. All right, for those of you guys who just walked in, let's make sure you got this. Here's the assignment. 1 through 40, 48, 49, and 50. Don't come in tomorrow, tell me you don't know how to do those last two hard ones. Figure them out. All right, figure them out. All right, they're very tricky. All right, very tricky.
Not for you, genius like me.
Not for the genius to sit in front of me, that's true.
Sir.